starting on that working example. Because when I did this yesterday, I didn't explain it all that well, why you complete the square to do this. Well, this is why. Okay, so if you have a squared value and it equals 64, all right? All I need to do is I need to isolate the x, get it by itself. So obviously I have to do that by taking the square root. Whatever I do, I'll take the square root of both sides. So x, and that leaves me with plus minus 8 as part of my solution, or as my entire solution. Okay? Now, the plus minus, okay, when you take the square root, or the 2 squared is 4, minus 2 squared is also 4, right? The other way to look at it is like this. What if I took this over, made it equal to 0, and factored it like I did yesterday? So I would get x squared minus 64 is equal to 0. Now what do I have? What did we do yesterday when I saw something like this? What do you know about x squared and 64? They're perfect squares separated by what? So it's difference of squares. Difference of squares. X minus 8, x plus 8 equals 0. When I solve for, I get x is equal to 8 minus 8. So when I take the square root, I end up with plus minus. When I factor it, I end up with plus minus. Okay? But this is all factoring. We're not doing factoring today. We're leading up to completing the square. So looking at the next question, x minus 4 squared is equal to 36. So I switched these up on that from your workbook, but whatever. So what's the first thing that I do? I need to try and get that x by itself. So how do I do that? Okay, so I need to get rid of this first, correct? So x minus 4 is equal to plus minus 6. Okay, now I got to get x by itself by adding 4 to the other side. So I get x is equal to plus minus 6, add 4, which means x is equal to 6 add 4, and x is equal to negative 6 add 4. X is equal to 10, and x is equal to minus 2. Okay? Check your solution at this point. Put this back in for x. 10 subtract 4 is what? 6. 6 squared is? Sure, it works. Minus 2. Minus 2 subtract 4 is? Negative 6. Negative 6 squared is? 36. So you can check your solution. It works way better, obviously, when they're whole numbers. But you can check your solutions. So if I get it to this form right here where I get the squared value by itself, then all I do is take the square root of both sides. So what are we doing in completing the square? We are creating a perfect trinomial square, and we make it into an x minus a situation, right? So let's look at another example. That's 32. Okay, so here's what happens here. I can't factor it like this. All right? Well, I could actually. So just to show you what we did yesterday, the easiest way to do this is to factor it. Make it all equal to 0. And factor it, right? Yeah. So what are the factors of a squared? A and a. What are the factors of 32 that add to give me 18? What goes into 32 that would add to give me 18? Give me factors of 32, please.
Well,
4 and what? 4 and 8. What do you got? That work, Dad, to give me that? Sure does. So there's my solution, right? Now, I'm going to do this a different way. I'm going to use completing the square to do it. So then I have to only take the square root. So what do? Brackets on this side, and add my blank in. On this side, minus 32 plus my blank. Okay, what goes in the blank right here? What is it?
9 squared.
9 squared, which is 81, right? Okay, so now I have a plus 9 all squared is equal to 81 minus 32, which is 49. Same exact situation that I had over here. And what did I do first? Square root. Right on. Okay, square root it. A plus 9 is equal to plus minus 7. A is equal to minus 7 subtract 9, minus 7, or sorry, plus 7, subtract 9. So do that again. Plus 7 subtract 9. A is equal to minus 16 minus 2. That's the completing the square method. When am I going to use this method? More often than not, I'm going to use that method as a resource right after I try factoring and it doesn't work. It's probably going to be the easiest method to use. Okay, so if you're not graphing it, all right, then you want to use this method when you can't factor. So an example of that is your next example in your book, in which you have t squared minus 8t equals 4. So I can't factor that. If I move the negative 4 over, there's no factors negative 4, that would give me negative 8. So again, t squared minus 8t plus a blank equals 4, add a blank. What goes in my blank? What is it? It's never a negative. Talked about that yesterday. Always that. Okay? Because if it's a perfect trinomial, right? This is a subtract, which you're going to see. So I have t minus 4 squared. So it's t minus 4 times t minus 4. So it's always got to be a positive right here. Okay? Is equal to 20. Square root it. T minus 4 is equal to plus minus the square root of 20. T is equal to 4 plus root of 20, comma, 4 minus root 20. Now, if you were in grade 10 right now, I'd say, okay, and even now, you might want to do it if you were to have a fraction. But I would break that down. Okay? So it would be 4 plus square root of 4 times square root of 5 is root 20. So that is 2 root 5. And 4 minus 2 root 5. That would be your solution. Don't feel you need to make that a decimal. If you're using your graphing calculator and you want to check it with your graphing calculator, then do it. Find out what it is as a decimal. Okay? So at this point, I'd go 4 plus root 20, punch it in, check it on my graphing calculator. 4 minus root 20, check it on the graphing calculator. Otherwise, leave it with the square roots. Okay? So when am I going to use this again? When I can't factor. Okay? And most of the time when I can't factor, I'm hoping that that's an even number. That way I stay away from fractions. Okay? All right.
So this isn't on the test on Monday?
Well, it is on the test in the sense that you have to complete the square on the test.
Yeah, That stuff
This,
is
to solve for it,
on
won't be on until next Wednesday's test.
Can you explain